Yeah, you'll never get more than two. Yeah, okay. Now, when I did this class, I just wrote it down in teacher's form. So that's good, but I made this.
Good afternoon.
I know, but yeah.
So today we will return to Python. We will continue with the high order function. Then we will cover things like filter, map, reduce, then list comprehension. The slides is simple. We will only have few slides, but then we will move to the Jupyter notebook with more examples. As I mentioned at the beginning, in Python, almost everything we are treated as an object, including functions. So function is considered as a first-class object in Python. So we're able to do a couple of fancy things. For example, we can define a simple function, summation. Then we define another function, which is called main, which contains some parameters. Okay, so nothing fancy yet. But then for this line, this is something which I consider quite fancy because the f, which is passed as a parameter, now we are used it as a function. So basically, the two parameter f and the arguments, this is passed into the function main. Then we will use f as our function, and then the argument as an argument for that function f. Then we print whatever result. Then if we look at this line, we call this function main. Then we are passing the summation to the f. Then 1, 2, 3 as a parameter. So that essentially to say, you can replace this summation here with some other function, let's say multiplication, division, or whatever you like, and couple with the corresponding function. Then the function main behavior will really depends on what you are passing in. So you can see here. So that this is trying to say we are able to pass function as a parameter to another function. So then your second function behavior will really depend on what you are passing to that function. Okay, so this can be very useful. We will talk more about this. Some people may be curious about what is this first line try to say. If underscore underscore main equal to underscore, if underscore underscore name equal to underscore main, what does that mean? If you are familiar with Python, this probably you're already familiar with this. But if you are new to Python, in Python, when you write a piece of code, we will use it in probably two ways. One is you try to execute the script. The other one is you try to import your code, your Python code, into another script. We have seen this, right? Where import like numpy.mp. I think you'll see these examples. So this is essentially to say, if your the current script is the one which you want to execute, then you will try to do this. And if your current script is being imported by another file, and this guy will not be executed. So this is a kind of condition check to check whether you are staying your main running thread. Yeah. If you don't get that, that's fine. I think anyway, you will meet this situation many times later. So also this is one reason, as you can see, we are allowed to using the underscore as a starting of your name. So because there's a lot of variable you don't want to be override by accidentally create your own user file name, variable name. So for example, like if you create your username with underscore name, you override some important system variable. So this is one potential usage why we allow underscore, or why we like to use underscore as one of the name scheme. Okay, so this is the first part. What the main message here is to say you are able to pass function as a function parameter. Okay, any question about this part? So basically, you can define a function, then you can just use that function as some kind of variable, pass that function name to another function, then you are basically you have a dynamic function which really behavior depends on what you are passing. Okay, any question about this concept? Okay, so let's see another very interesting example to return a function as a result of another function. So in the first example is passing a function as a parameter. Now we will see how to return a function as a function result. So now we are defining two functions, which is the first one is called add two numbers. Then this is add three numbers. So the behavior of these two functions is very similar. Basically, you are depends on how many parameters you are passing. Then I just return the summation of those numbers. But the difference is depends on whether you are passing two numbers or three numbers. So slightly different. Then at the runtime, sometimes you don't know which function to call, right? But of course, this is a toy example. You have a much neater way to do this. But let's pretend we don't know what's a better way. So we want to get another function as a selector. So this function is essentially trying to say, based on the input number, 2 or 3, I want to pick the right function. All right. So basically, you can see here, if I do a check to say, if my number length equal to 3, I will return add 3 numbers. Otherwise, I return add 2 numbers. So this function essentially tries to return you the right function to apply to your input. Okay. So, but this is not the key part. The key part is try to see here, we are returning a function as a result of a function. So we are passing a function as a input parameter of a function. We can return a function as a, yes, questions.
So is that returning like essentially calling the function, or is it
No, it's just return some kind of pointer. You can say f equal to get something, right? Then the f will be holding the right name of your function. Right? Then you can apply the f to a parameter. Then this is just some toy example, but now next we are going to see something more interesting. Okay. This is called the first example we want to introduce is called filter. So I guess since you are from easy, you know what we mean by filter, right? So here is essentially it's very interesting is to say, okay, let's say I give you an interval, a list. Then I want to have a very neat way to filter out things which I don't like. Okay. So how to do that? Very simple. We will define a function called filter. Let's forget about the list. The list is more for output. Try to convert the filter function output into a list. But if we can concentrate on the filter part here. So we have function called filter. Then the filter taking 2 parameters. Okay. So this is a first parameter. This is a second parameter. So the first parameter is a Boolean function. The Boolean function will give you true or false. So only do one condition check to say, okay, this is true or false. Then the second parameter will be an interval, let's say a list or a tuple. Okay. So in this particular example, we can see we contain 2 parts. The first part is something mysterious. I will show you what is this next. Then the second part is a list, because we have a list 5, 7 contains a list of numbers. So this Li is a list, and the first element is a very mysterious lambda things. Okay. But if I map to the definition, we will know this mysterious lambda1 should be a function which will return you true or false. Okay. So now let's look at what is lambda try to do. So lambda function is what we call anonymous function. Is a function without a name. So the format is to say you define a lambda as a keyword, then you have the arguments. Arguments is like what arguments you are passing into a function. Okay, so this is a function input arguments. Then this is expression. This expression is to say what you want to execute within your function body. So although a lambda function is an anonymous function, but it still contains the argument and the expression. Right? It contains arguments and then to say what I want to execute. So I give you, for example, here, this is a lambda function. I have lambda keyword, then I have input. I have this xy is my parameter. Then the main function body is x plus 1. So if I define this, then of course here I try to assign this to G. I already give a name or at least a function variable. So now if I can use that as a G56, as you can see. So this lambda essentially equivalent to a function to say function G. You can define a function G with the input xy, and inside the function body you say return x plus 1. So essentially almost the same. But now we are, for many situations, using lambda function, you are more convenient. So for example, as here, this is much convenient way to define a function, a Boolean function. I call lambda. Then this is my input x. Then the main body is trying to say, is the x is a equal number or not? Is an odd number or not? Okay, so right, I just want to, in the body of the function, I just try to check if x mod 2 not equal to 0. Is that true or not? All right. So you can see define anonymous function here is very convenient. You just write a simple expression. Actually, you are implementing a function there. So what this essentially tries to say, because I want to filter a list. I give a list, I want to filter the list. I want to drop everything which my condition does not hold. This here is my condition. I want to check if the current element mode 2 not equal to 0. If that is not satisfied, I will drop that element. If that's satisfied, I will keep it. Is that all right? So for example, well, I give this list, then I try to pass through my filter and I apply this conditional check. I will say, basically this is try to say whether this is an odd number. If not equals to 0, if true or not, then I will check for each element whether that is true or not. Yes, question.
This will keep the odd.
Yes. Try to keep the condition which is true.
Okay.
So here, there's two things you need to remember. First, yes, question.
So does the filter just automatically go through all the elements?
Yes, it will automatically iterate over over the list. Actually, in the Jupyter Notebook demo, we were going to show if you implement your own way to do the filter, to do those how we will implement. We will see that. Yeah, but here it's just like we try to hide everything inside the filter function. So here, there's two things you need to remember. One thing is what is lambda function? Lambda function, just think lambda function is a anonymous function, right? Whenever you see lambda, this is a keyword. Then what before the before the colon will be your function input, just like a regular function input. Then the things after your set after your colon will be your function body. So it's just a regular function. The only difference is I do not need to give a name to this function. All right. And then the second thing you need to remember is what is the scheme of this filter. Filter basically take two arguments. The first argument is a Boolean function, will return true or false. The second argument is an interval. So then you will go through every element of your interval. If that function is true, then you will keep that element. Otherwise, you will throw away, just like name filter doing. So in this way, you will get a new filter. For example, when we are talking about this Python basics, you remember I have a list. I want to remove, let's say, remove an element, right? I told you I will remove, this function will remove the first occurrence of the element you like, right? At the moment, I believe you have a question to say, hey, if I want to remove everything of that element, let's say if I have several 5 in my list, I want to remove all 5. I told you one way you can do a simple loop, right? You just try to check. You just keep calling the remove until you do not find anything. The other one, I say later you will find there's a much elegant way to do this. Maybe there's at least potential 2 ways to do this. One way is consider using filter, right? If you're using filter, think about that. How easy to remove elements, a particular element. Remove all the occurrence of an element from a filter, from a list. Think about how to do that. Yeah, it should be simple, right? Yeah, you can do a small exercise at home to say, how do you implement that? But that is very straightforward. All right. Any questions about the filter? Great. So then the next thing we will move to is something we call map. Yes, question. Oh, yeah. Lambda is a building thing. Yes. Yeah. The first time when I see the Lambda function concept in Python, this actually remind me, not exactly the same, but remind me some kind of inline function like in C. You try to, for convenience, you try to write a function in one line. So it's a little bit similar. Map. This is try to some kind of similar concept as filter, but filter is very simple. You just try to drop things you don't like, which or don't pass your filter. And the map is try to say I have a particular operation and I want to apply to each element in my interval. Okay. So again, let's look at. So again, it has 2 input. Okay, the first input is a function to apply. The second one is an interval, a sequence, a collection, or object. For example, I have an interval called item, which contains 1, 2, 3, 4, 5. Then I try to create, I call map, which contains 2 parts. The first part is an action I want to apply to each element to my interval. The second one is my interval. So basically, we define the function here again using a lambda. Let's take a look at lambda function. See what is this lambda try to do. Take a look. See whether you can understand what this lambda try to do. Yes.
Wait, so like we're not changing items, we're making a new list?
Yes.
Okay.
Yes. So see whether you can understand what this lambda to try to do. This lambda is try to take x as an input and try to raise to power 2 to that input, right? I hope you have seen this. Okay, are we fine with lambda? Yeah, if you are still very confused about lambda, it's very easy, but if you are confused, just let me know. Yes.
So if you're applying like the lambda part of it, it's going to take everything in the list and then two, then what is the map going to like for that?
Yeah, map is think this is more like somebody already write a loop for you. It's inside the loop. It will take one by one examine the element of your interval, let's say the list here, then try to apply what you define in the lambda to that element, then append it to a new list. So, you can see here, this is an action you want to apply to all elements in an input list, right? And for each element, you try to take that element as x, and you try to output x raised to power 2. So that essentially try to say, I take this list, I will go through this list, and for each of them, I will try to put a power 2. So I will get the output here, the squared will be 1, 4, like 9, 16, 25. Yeah, so you will get a new list. All right, yes. Sorry? You mean this guy?
Yeah.
Oh, this is a try to, because when you do the map, you will get some, probably a maps object or something. And then you do the call the list, it will try to extract the list out. Yeah, so you will make sure the squared is a regular list you are expecting. All right. We're fine with the map, right? So I will proceed. So now we are going to see another example. I think that this example actually is pretty interesting. So we define two functions. One function called multiply, one function called add. Of course, it's very simple function. One is you return the product. One is return the summation. Then I define a list called functions and contain two elements, multiply and add. So remember, we have a list, list of functions here. Okay. So now give yourself maybe 10 seconds to look at this piece of code, see what this code trying to do. Does anyone want to give a try to say what this code trying to do? Yes.
So for 0, 4, it's applying x of I, so the function x of I, or the function of I to that number. It's like it's gonna multiply, do whatever multiply does to I, and then do whatever add does to I, and then put those values.
Yes,
so
absolutely.
It'll be like for 0, it'll be 0, then 0. For 1, it'll be 1 and 2.
Yes, perfect. So I hope everybody see this. So we still have a map, right? The map has two things. One is an action you want to apply to each element in your list. Then the second element is a list. But pay attention, the list here is a function. So if I take the first element, it will be multiply. Take the second element of that list will be add. Okay. And then what I try to do, I define a lambda function. I will take a x as a input. Then I will call a xi. What is I? I is your variable, which is each is your loop, right? Each time I will take 0 to 1, 2, 3, 4. I think that each time the I will taking a integer value, but the x we're taking a function name. I hope you see that, because this x is each element inside this function, which is contain two elements. So the first time the x we're taking multiply, then the multiply parenthesis I, You see that? So this is very fun. So this is like is what we are trying to discuss at the first slides. We can passing a function into another function, something like that. Yeah. Right. Do we see that? Although the lambda here is a anonymous function, but it takes a function as the input. Any questions here? Yes.
So why would you use this instead of a for you faster? Or
Oh yeah, this is more for illustration. Just try to show you can potentially use this.
no, but why would someone use map lambda over a for like
Oh, I think that this is much simple, right? You don't need to. I think that you will see the reason. You will appreciate this more when we give you the Jupyter. If you don't do this, especially for the next slide we are talking about reduce. I mean, this is a very systematic way, right? If you don't do this, you have to write your loop, and each time inside loop you have to redefine, write a new things about your function. So basically, you are writing the almost the exact same scheme to process your interval, but you are writing a chunk of code. But now you are able to writing a single line, and which with a lot of flexibility. Yeah, of course, this map filter is not the best way to do this. I will show you some more convenient way, which is called list comprehension. Yeah. So that is even more flexible. So there's another concept called reduce. So reduce is how to say? It's try to you get a list, and now I want to reduce that list to a single value based on the action I define. So basically, it needs two input. One is a function to apply, another is a sequence to iterate over. For example, I give you a list with numbers. If I call some possible action of reduce is to say, let's say if I reduce them into a summation, I sum all the numbers together, right? That is a very possible action we may consider to apply the reduce. Basically, you are rolling over your list of elements and reduce them to a single output. Okay, so let's say, how do we define the summation action using reduce? So we can do this is our list, which contains a couple of integers. Then we will call reduce. Then this is our first function. This is our second element, which is an interval list. By defining this one, I would tell you this function, this reduce will sum everything together, give you a single total summation. You may feel very curious, hey, how that be achieved? Because this lambda seems looks only try to adding two things, right? Okay, so what I suggest to understand this is try to think in the following. Although we do not implement that gentleman tried to say why we are using this. If we want to achieve this, we need to have an implicit loop there. Like you start from, think about if you write in a loop, how do you write this? You will have let's say a total sum. You will initialize that equal to 0. And then you will start to iterate over your list, start from the first element, right? Then you will try to adding each element to your total sum, right? Because you start with 0. So in the first iteration, you are adding the first element. Then your sum is updated to now contain your first element. Then you move to the next element. Then you're adding that guy to my total sum. Then my sum will contain 2 elements, right? So if you think in that way, if you say my x initialized with 0, if my x is my total sum, Then the y is my next element in my list. What I need to do is just adding that 2. If you think in this way, can you understand this? It's very easy, right? So basically you are iterate over your list. And each time I'm adding my current element to the to my final result. Yes.
What if the number of elements in the original list isn't an integer multiple of the number of arguments of the lambda?
Again, so can you say that question
Sorry,
again?
what if the number of elements in the list isn't an integer multiple of the number of arguments to the lambda function?
But this is we only care. We are moving the
It's
pointer
like in
one
pairs,
at a time.
right? But what if there's
No,
like-
not this is pair. What I try to say is try to think x as your current sum. Y is your current element. You initialize your x with 0. Then each time the y will be your first element in your list. You adding them. Then you move to the next. But now your x will be your current sum. You adding your next. So you do
okay.
not. Yeah.
I got it.
Yeah. So, of course, you can easily replace this summation as a plot, as a, let's say, as a time multiplication. You will multiply everything together, right? Oh, yes, questions.
So when you say lambda x comma y, is that because the operating function or operator map returning next is x plus y, so it's like however many variables you're operating with, you put that for the comma separation type of code.
The last sentence. What is your last sentence? Okay.
So for like x comma y,
Mhm.
if you're going to try to do like x plus y plus z, if you put x comma y comma z, or there's like 3 variables up to your manipulating with.
So I didn't get. I apologize. I didn't get. Could you? I mean, bear with me. Repeat your question one more time. Yeah.
So x comma y colon x plus y.
Yes.
If I wanted to change that to make it 3, so like x comma y comma or x comma y
Oh.
comma z.
So here, as I mentioned, if you think x is your current total sum, y is your next element, we do not need 3 elements here.
Would
Right.
it go faster though?
Yeah, I haven't think about that. You can try that out. Yeah, you can try that probably at home to see whether that is possible. Yeah. Yes, probably is
Well, it's
possible.
kind of like his question. Let's say it was like x plus y raised to z. So it's not just x plus y plus z. So that means you have to go through it. So then if you
Yes.
do x comma y comma z, will it go to the next one or will it go to the next 2?
I think that you guys are very creative. I think that just give a try. I honestly, I don't want to give false answer. Yeah. I haven't tried that. Yeah. But usually I use the reduce is I try to adding everything because this is a very one very common operation in statistics. You want to, let's say, do an average. You want to compute many things. Actually, a lot of actions. You adding everything together. Yeah. So this is going to be very useful. But yeah, I encourage you to try. But mostly, I may think this is anyway. Yeah, I don't want to give. So I think it's a good question. I don't know. So yes. Let me move further. Yeah. So I'll say we can, of course, you don't need to always using lambda here. You can define your actual function and pass the function to your, because remember you can pass your function as a input parameter to another function. So you can always define your function. So this is what I try to say. Probably this gentleman think is right. You can define your function, whatever your function. What I only unsure is when you define a lambda, what's a better way to speed up? Maybe there's a better way. So think about that. Yeah. I don't know. And the reduce is not a building. The lambda is a building. The filter is building. Map is building, but reduce is not a building function. If you want to using the reduce, you need to import functions. We call from function tool import reduce. Yeah. Okay. So this is the most exciting part called list comprehension. You can see many things we just talk, we can implement them using list comprehension. So this is a simple way of creating a list based on iterable Python object. Element element in the new list are conditional including and transform as needed. So honestly, the best way for me to understand list comprehension is we start to just memorize the formula. Okay, it's a little bit abstract, but if you remember the formula, it's very easy to see what happens. Okay, so first, it has a very strange formula at the beginning, but later you find it's very natural. So it will have first, it has a output expression. You will start with the output expression, okay, and then it will have a full 4 item in interval. So this has this green part. This is a kind of iteration. I'll say, for now, understand that as an iteration. Okay. And then there's an optional if condition at the end. So what we try to do here is to say, if I have an interval, right? You define an interval, then I do some kind of like a for loop. I have 4 items in interval. So each time the item will carry one of your elements. So until you will iterate each element one by one. Then for each element, think about you are iterate over some iterations, for loop iterations. Okay. During each iteration, you will try to think what you are going to put here. You are appending something to the output expression. And there's an optional if condition. You just say, during each iteration, do I need to check something? So for now, let's understand that way. Of course, I will break my words because there's a couple of different forms to think about that. Yeah. So, but for now, let's think in this way. If this is your first time to meet the list comprehension, let's think in this way. You have an iterable object. Then think about you have a for loop to go through each element. At each element, you will try to see if you have any if condition to satisfy or not. Okay, then you will try to append your current whatever in your current iteration to your output expression. Okay, now let's see an example to see what does that mean. Okay. So now I have a number list 1, 2, 3, 4, 5. So now you can see how compact list comprehension will be. So this one will give you the squared version of this list. Take a look to see, match this with our mysterious formula and see does this make sense to you? First, take your 10 seconds to look at this, then we will go through together. Okay, so first, this is we are looking for a for loop, right? For n in numbers. That is essentially to say the n will take each element in your interval. And then I have a if condition to check to say if n greater than 2, it's more like in the filter, we have a filter condition, a Boolean function to check if that is. Then if that is satisfied, then probably I will be able to append my current things to the output expression. So this will be a squared version of your current element. So this essentially try to say, for whatever n is greater than 2, I will put its squared version append to a new list. All right. Are we fine with this example? Yes.
Basically, what this does is it filters and maps at the same time.
You can say
In this
that.
scenario.
Yeah, you can say that. You can implement the filter, right, with the if condition. You can do the map. Yeah. So, for example, let's say if you want to remove all occurrence of a particular element, you can also using this way, right? The list comprehension is a single line. You don't even write a loop. Any questions about? We will see many examples later. It's very straightforward, but if you use it right, it's super convenient. Yeah, we will see many more examples about list comprehension. Probably not today, maybe or during Wednesday. So are we fine with? Yeah. So I think that this is also. I think the one gentleman asked a couple questions. Why we care use this? So probably it's, of course, it's easy to write. The first advantage, you save space, you do not write codes, right? And also, since we are define things in a more systematic way, we are able to do probably a little bit more optimization inside. So in general, our understanding is it's more computational efficient. Yeah. So this is actually, especially today in data science, if people give you highly optimized, let's say, matrix multiplication, it will so much faster than you are really write your code to multiply, because everybody know how to do math. Let's say to multiply a big chunk of matrix with another matrix, right? But when you do a loop to multiply them, you are going to be slow. And if some people are really spend effort to optimize this, probably they play some tricks inside. They have a better way to do this calculation for you or optimize it for you. Then it will be much faster. So in general, if we are able to compact many things into one common way, we can spend effort to optimize that guy to make things in general a little bit faster. Because think about this, you go through a list. The list is not only 5 numbers. In this example, you have 5 numbers. Maybe this list contains a million numbers. Think about that. With 10 million numbers. Can you do that? If you write a loop, maybe it take a while. But if you highly optimize it, I don't know whether how fast is optimized. This is, I just try to adding a little bit notes here. Yeah. So whenever you access a huge amount of elements, optimization is very important. So for example, also today we are using GPUs. Can you write a GPU optimized version to do certain things? This will improve things a lot. Yeah. Okay. So there's another form of list comprehension here is we can add in an if-else condition. So basically the format, it will be out expression and the if-else clause. Then you have, again, the for loop as before. Then you have condition, if condition as before. So only additional things is the if-else here. So let's see, what does that mean? We have number, a list of numbers. Then we will try to say square equal to expression, output expression, if number smaller than 10, else big. So this is what the difference from the default case, which we show here. So now the output expression will depend on a condition. So here, I will still iterate over my using the for loop to go through each element of my number. And then for each number, I will check if this is a mode 2 equal to 0, if this mode 3 equal to 0, if that's satisfied. That means if I mode 6 equal to 0 in some sense. So this guy and this guy. Then I will try to say for the element satisfy my condition, I would try to check if that guy is smaller than 10. If that is true, I will give you small. Otherwise, I will output big. So if I go through, I need this guy to be true and this guy to be true. That means I only have 6 and 18, these two numbers. For the 6 is smaller than 10, so I'll give small. Then for the 16 is bigger than 10, I will give big. So the output will be small, big. Okay, do we get that? Yes, questions?
So for those if statements on variables,
Yes.
are those naturally set to the length?
Yeah. Yes.
Modulo 2 and 0.
Yes. Yes. This is a, as you can see, this is conditions. So basically each condition need to be satisfied.
How would you set it to one operator?
You can, because this is a, since this is a if condition, you can, of course, you can put your using those operator to enforce a combination. Yes, questions? Yes. So I apologize. I think that we are all speak behind a mask. Sometimes I'm not here super clear.
Sorry. So like, can you have like more than like two conditions? Number is not that, and then you have an output.
Yeah, this is my in my understanding is you have a little bit rigid. You have if else. Yeah. Yeah. So then the other there's another very how say very important and can be very powerful concept is called nested list comprehension. Okay, we will see more examples in the Jupyter notebook, but let me give you a little bit flavor here. So I have a now I have a list, which is actually is a list of lists. Okay, so this is the most simple nested version. So now what I can do is I can do follows. Take a look, see what this guy tried to do here. So this one is actually is much easier to understand compared with other nested version. Because what you need to understand this is just try to plug in into our formula. Try to think about how does this correspond to our formula? All right. First, do we have a for loop there? We have, right? We have a for loop here. For x in n in L. L is our list, right? Do we have an expression here? Yes, right? Our expression here is this guy, right? But the difference is our expression inside, it looks like it's another list comprehension. So that is what is found here, right? So basically, you will do for x in L, you will iterate over L. For each element in L, you will assign that to x. So the first element is what? Is this guy, right? This is the first element in my L. This is the second element. Then for each of the element, I will try to output something. But now my output looks like it's another list comprehension. It will want to go through my current x. The current x is what? The first x is this guy. So then I will try to check each element in my x and output the float version of that element. So basically what this piece of code we try to do is it will try to output exactly the same thing as what you have as an input. Any questions about? Yes.
Wait, so would L2 be another nested list?
Yes, it will be a nested.
It will be a nested.
Yes,
Okay.
yes. Yeah. Think about how if you want to flatten this into one list, how to do that? Of course, I will give you answers during Wednesday, but you can think about it. Yeah, this output will, because we have a bracket here, so it will give you another list. I think I will stop here, and I see you on Wednesday.